I'm Professor Othmer, and I'm teaching at Cal State Long Beach since '84. I know all the finite element textbooks. None is in color. Now I found a publishing company in India, and they published finite element methods 1. Can we show the and that is not only the introduction to finite elements, but there are also all the menus for solid modeling, and I name it therefore NX Siemens and NX Nestran. Also a comment, NX Nestran is the oldest finite element package, 50 years since the first developments, and still number one. The second volume is named Finite Element and Finite Volume Method. Finite volume method mainly for fluid dynamic, and also then direct approximation of differential equations. Now it is clear that the approximation of differential equation is superb of the finite volume method and the finite element method. They have not the elements and they have a different approach. Finite elements are based on Ritz. Finite volume method is, I think, a simple finite difference method. These two volumes, each volume has 600 pages in colors, very important in dynamics, and I can also show them. It's not only for one class, for many classes, and there are here the solid modeling for, and then afterwards the generation of a mesh, and so on and so on. The whole numerical methods available today are summarized here in these two books, and I'm not very arrogant, but I can say here you find my research and my teaching after 50 years. Before I came here, I was 17 years in Airbus in Munich in responsible position, working with Nestran and working with Strudel and all the big project, the first Airbus structures we simulated, and also the Tornado fighter project. You can read this in my profile, what is my background. The difference here, these books, they are in colors, and maybe I show another. It's very important that you have in dynamics colored menus, and they are not only calculated, there is a description how to use the colored menus. And the software behind it is NX Siemens. Second very important topic is how expensive are those books. McGraw-Hill says in engineering you don't need colors. They were advised from professors being not up to date what is going on in industry. Every car is built using software, Siemens or Airbus from Airbus. The, the difference today is that every part in industry for cars is stored as a solid model file. So you can immediately, if you make changes, do the simulation. Simulation is the calculation of stresses and deflections. And for that, you have first to learn the finite element method. When you have only frames and beams, you have practically one local stiffness matrix. And to learn easily the method, we developed a software FAB, and we show a few examples. Before that, I have to say the price is unbelievable for American standards. 600 pages in colors for one volume costs only $25, but to ship it over here costs $50. So 500 rupees in Indian currency, but 70 or $60 for colored 600 pages is very cheap. Macro-Hill said we cannot do it in colors because it would then cost $400. So this is unique. It has to do with the different currencies. And the second volume has the same price. There is everything on the internet. You can order internet via Visa card. The second volume, also 600 colored pages, where appropriate, we have the pages in colors, and also $25. But to ship it over here, it takes a week, maybe $50. So for $70, you have it here. But I said before, the numerical methods known for all engineering problems, numerical problems there, Ritz method, Galerkin method, and direct solving differential equations with the so-called Weierstrass method, that is an advanced finite difference method. The first pioneers were Hermite and then Kollatz in Germany and Albrecht in Germany. So my advantage was that when I supervised thesis, I could read the German publications. And I grew up there in Braunschweig at the Technical University, and then there were also famous professors. My teacher was Hermann Schlichting, and Hermann Schlichting was in Göttingen the assistant of Ludwig Brandl. And everyone in engineering knows who Brandl was. And Hermann Schlichting wrote the book, copy or translated 7 times, and has 800 pages. And I made my PhD under the supervision of Professor Gersten, Hermann Schäfer, and Professor Schlichting. He was my teacher. Now, how to learn the finite elements. And there we have developed a unique procedure, and that's practically an animation. For example, how to assemble the local stiffness matrix to build the global stiffness matrix, you see it as an animation. The same, we have only one input, no learning experience, everyone starts playing, and the intention is that every student should have this FAB to play because he learns 100% what is the finite element parallel in the book. He finds the calculation, what is cumbersome sometimes because it takes some work. But the students learning finite elements, they also should be aware of the theory in detail. So for one-dimensional problems, beams and frames, the finite element method is exact, what is not known. And we have as an output for every moment distribution, displacement distribution, graphical outputs beside the overall deformation. And the boundary conditions are by special symbols. We have to give some examples that you see how unique that procedure is. And due to my knowledge, maybe hundreds in my class, 100 students, have learned it the last years I was teaching. And there is nobody who said you can find a parallel uh, documentation. Maybe the next step should be introducing FAB. It was my son also studied here and he made it for his master thesis. And I learned from him Visual Basic. And we say for engineers, Visual Basic is better than MATLAB. It's better than C++. C++ is the language for compilers. So the next step should be to show some animations to learn finite elements. So that should be now the second part.